So, today we are going to be learning about triangles. And in case you don't know what a triangle is, you should look at Mr. Green Pac-Man's mouth. That's not. Imagine if there was a straight line instead of a curve for his mouth, and then that would be a triangle. But don't worry, we're going to see lots of triangles in the rest of this slideshow. So you will know what a triangle is by the end of this, and you will also know multiple different ways to do cool things with triangles. So without further ado, let's get started.
Okay, so the triangle lesson is just gonna be 1 day long, not 2 days long. The day 2 stuff over here is like stuff you guys can learn more about like on your own, or if you have like questions about it, you can like ask us if we like have time at the end. But yeah. Okay, so what is a triangle? So a triangle is a very simple shape. It just has 3 sides. And it obviously has 3 angles. But this very simple definition actually creates a lot of cool properties of a triangle. So the most obvious one, you guys should know, this is very important, but the angles of a triangle always have to add up to exactly 180 degrees. If they don't add up to 180 degrees, then it's not a triangle, period. So all this is very important. If you don't know this fact, you should like write it down on your like arm or something so you always remember. It's very important. Okay, continue. Kayan, you want to talk about triangles?
Sure. Okay, so there's 3 types of big, groups of triangles. And the first one is equilateral triangles. We really like these because they're simple. All the sides and angles are congruent, so they're like the same measure. And then isosceles triangles are very cool. They're probably my favorite. So they have like 2 sides, and then the corresponding angles at the bottom that they make with the base are also congruent. So as you can see in the picture, one angle at the top is like smaller, but those bottom 2 angles are the same, and then those 2 like slanted sides are also the same. And then finally, we have scalene triangles where no sides are of equal length and no angles are of equal measure. So they can be a little hard to work with. Yay, Bunny agrees with me.
I'm trying to move on. Hold on. It's stuck. Okay, got it.
Oh, apparently there's more. So these are triangle types according to angles. So an acute triangle has only acute angles, which means that angles are all less than 90 degrees. So you can think of it as a cute tiny little triangle with tiny angles. And then we have a right triangle, which you'll probably see a lot, which has just one right angle in it, so 90-degree angle. And then finally, we have an obtuse triangle where one of the angles is greater than 90 degrees. And then, yeah, that's about it. So classifying it based on the angles.
Okay, Ishani, you want to go over this?
Yeah. So pick 2 of the terms we learned to describe this triangle. So okay, so we can categorize it by the side lengths. We can categorize it by the angle measure, and we can categorize it by the side lengths, right? So look at the angles. Are there any like special angles here, right? Remember we said that if we have a 90-degree angle, it would be a right triangle, and we can see that this is a 90-degree angle. So yes, and we can see that none of the side lengths are the same, right? So the term used for that is scalene. And I see that some of you are saying like the angles add up to 180 degrees, and that is true, but that's not like a term we would use for this triangle, right? It's not like specifying this triangle. Like it's not like it's true for all triangles. So it's not really something extra that we need to say after we say that this is a triangle. But yes, it would be a scalene right.
Okay, Yolanda.
All right. So let's pretend you're going to draw a triangle with side lengths of 8, 12, and 22. But a very astute observer would know that that's not actually possible. And if you cut out like strips of paper and tried to make a triangle with those, you'll find that you can't actually connect them together into a triangle. And you can also kind of imagine this because like you can think of you have a line of length 22, and then you can like fit both of the smaller lines onto the line of 22 with still a gap in between. So these three lengths cannot form a triangle. And there's an easy way to determine in general whether three side lengths are long enough to form a triangle. So the two shorter side lengths, the sum of the two shorter side lengths has to be longer than the third side length. So for instance, if it was 8, 15, and 22, that could form a triangle because 8 plus 15 is 23, which is greater than 22. But if it was like 8, 14, and 22, that wouldn't work. That would just be a line. And if you go smaller than that, it also won't work. So this is just an important tip to help you guys recognize when a triangle is impossible and when one actually exists. Yeah, so this is the rule I was talking about. If we make C, if we set C as the longest side of the triangle, then the sum of the two shorter sides must be bigger than the third side if we are going to have an actual triangle.
So this is a very important formula. Remember this one. Okay, so let's just do like one or two of these. So let's do this number 2. If that's a real or an impossible triangle. So it's a triangle with sides 6, 9, 14. Can you make a triangle with those side lengths, or is that impossible? So real or impossible for number 2. Yes, it is a real triangle because if you go through all of the possible side lengths, 6 plus 9 is greater than 14, 6 plus 14 is greater than 9, and 9 plus 14 is greater than 6. So this means that it is a real triangle. Also, I'll go back to the slide with this formula real quick. Just for if you need to write it down, it's just A plus B is greater than C. Any two sides of the triangle have to be greater than the third side. So take a picture really quickly. Okay. Back to the problem. Okay. Now let's do number 6 down here. A triangle with side lengths 3, 8, and 12. Can that make a real triangle, or is that going to be impossible to make a triangle with? Yep, this one is impossible because if you test it, 3 plus 8 is not greater than 12. So this means that when you're trying to like connect, like if this is a side with length 12, if you try to like connect side of length 3 to the side of length 8, it's not greater than 12, so they will never touch and it can't make a triangle. Yep. Okay, I think you guys get the point. So we're gonna move on. Okay.
I guess I can do this.
Sure.
So next, we're gonna do find the area of a triangle, which I think some of you guys might already know, but so the formula, if you don't know, is base times height, and then you do 1/2 of it. So the reason is like if you can draw if you like duplicated this once and then made it into like a little parallelogram type of thing, then you can find the area by doing base times height. And now the triangle is just half of it. Or you could do that. But yeah, so then the triangle is just half of this quadrilateral shape that you create. So now you multiply by 1/2. But anyways, let's apply this very well-known formula. So yeah, you guys are right. This area is 12 because 6 times 4 is 24, divided by 2 is 12. But let's move on to the practice problems. Okay, so find the area of this triangle. So remember, it is base times height times 1/2. Yep. You guys are right. So let's do it together. We have base, which is 18, times height, which is 6, times 1/2. Oh, can you guys
Whoops.
see?
Sorry.
Is 54. Yep. Okay, and then if you click next, I think there's another problem.
Yep. Okay. All right.
And then now number 2 is a word problem. Sasha made a triangular frame out of wood. It has a base of 6 inches and a height of 2.5 inches. If she wants to cover the frame with fabric, how much will she need? So what area should the fabric be to cover this triangular frame? Lots of speedy answers. Yeah, so you guys are right about the 7.5, but I do want to touch on one thing afterwards. So 2.5 times 6 times 1/2 is indeed 7.5. But this is a word problem, and another thing we should keep track of is it's not going to be inches, but since it's area, it's going to be inches squared. So the first problem didn't give us any units, so it doesn't really matter. But the second problem is a word problem, so it's important to know this.
Okay.
Yep.
Okay, so now let's go. So 160 bushels of corn can be grown per acre, and Rosie's land is shaped like a triangle. Given that an acre is 43,500 feet, how many bushels of corn can go? Okay. Can you all hear me, by the way? Like,
Now I can. Yeah.
yeah. So,
Can't hear you.
okay, okay. Okay, I'm going to just repeat the question again for any of you. And then I'll give you all like a minute and then I'll go over it. 160 bushels of corn can be grown per acre, and Rosie's land is shaped like a right triangle. Given that an acre is 43,560 feet squared, how many bushels of corn can she grow? So, okay. Remember that you are going to be doing more than just finding the area, right? Because you have to find the area, yes, but you know that 160 bushels of corn can be grown per acre. So you have to do a little bit more than that, than just the area. Okay. Okay, so most of you are on the right track if you are wrong. But if you are not wrong, then good. So I will start off the problem by finding the area, right? You can continue solving it while I'm explaining. Right? But basically we want to do 660 feet times 1,320 feet times 1/2, right?
It's
And
okay, you can do it.
yeah, okay. So this would be equal to 435,600, right? 435,600 feet squared. So that would be how much area Rosie has, or how much land Rosie has. But now we know that 160 bushels of corn can be grown per acre, and 1 acre is 43,560 feet. So what I'm going to do is I am going to first see how many acres of land she has, right? So we have 1 acre is equal to 43,560 feet squared of land, right? So we will get that she has, so we can see that the units of feet squared will cancel out, right? Sorry. We can see that the units of feet squared are going to cancel out, and we are going to get that this is equal to 10 acres of land that she has, right? So she has, okay. So she has 10 acres of land, right? So what we are going to do is we are going to see how many bushels can be grown per acre, right? So okay, so 10 acres of land multiplied by 160 bushels per 1 acre, right? Is the math that we are going to do. So we are left with 1,600 bushels of corn that she can grow. So that would be our answer. So the thing to note here kind of is that we are multiplying by something that was like equal to each other, right? So we know that 1 acre is equal to 43,560. So we multiply by 1 acre over 43,560 feet squared because those are equal to each other. Then we know that 160 bushels of corn is equivalent to like how much can be grown per acre, right? So we multiply 160 bushels by over 1 acre by how many acres we have in order because we know that 160 bushels is equivalent to like the acres, right? Is how much we can grow per acre. So that's how we get the answer. So most of you got the 435,600 as the area, feet squared as the area, and you are correct, right? But you needed to read the problem in order to get from finding the area to finding the actual answer. So yeah. Do you have any questions? Because quite a few of you just did not get it right. Okay, do you all understand? If so, just type yes in the chat. If you do not understand, you can say you do not. And you can private message me if you have any questions. Okay.
Okie dokie. Then let's move on. Yay. Okay. Ooh, cool topic. Yolanda.
All right, now we are moving on to something very important, which are special right triangles. So, and the Pythagorean theorem. So hopefully you guys know what that is. All right. So before we get into it, there's some special terminology that will help you guys tackle the rest of this section. So a triangle, a right triangle has two legs. There's like the long leg and like the shorter leg. And then the side that's not one of the legs is the hypotenuse, and that's also the longest side of the triangle, and it's also the one that's like across from the right angle. So that's called the hypotenuse. It's a fancy word, but you guys should become very familiar with it. Oh. All right. And finally, we have a line called the altitude, which is drawn from the vertex with the right angle to make a right angle with the hypotenuse. And you would use the altitude, like you could use, if you were given like the hypotenuse and the altitude, you could calculate the area of the triangle. But you could also do it with the two legs if you were given that info. So that's just something important to know, in case, depending on what type of information you're given. But now that we're familiar with this, let's move on to the next slide. So, this should hopefully be a refresher, but this is like a super duper important formula, the Pythagorean theorem. And so if a triangle is a right triangle, then you can find the side, one of the side lengths given the length of the other two sides. And that is using the relationship a squared plus b squared equals c squared, where a, b, and c are the length of the sides. And remember that c has to be the hypotenuse. So basically this is saying that if you square the side lengths of like the two legs, then you'll get the square of the length of the hypotenuse. And then with some like square roots and subtraction, you can figure out the length of any of the sides. All right, so let's do an example problem. This is a right triangle. Unfortunately, the angle is not labeled, but it is a right triangle. So please use the Pythagorean theorem to find what x is. And once you're done, type your answer into the chat. All right, so I see a good number of answers. And yep, the answer here is 13. So, if we were going to do the Pythagorean theorem, we would do 5 squared plus 12 squared equals x squared. So then we calculate each of those. 5 squared is 25, 12 squared is 144, and 25 plus 144 equals 169. So that equals x squared. Now if we take the square root of both sides, we get that 13 equals x. And so that is the length of the hypotenuse. And another way you could know this is if you memorize the Pythagorean triple, 5, 12, 13. But there will be more on that later in this presentation.
This is a cool visual for why it works. You can see like each of the sides of the little triangle here has like it's a square. And the sum of the squares of the legs, so the sum of these two smaller squares perfectly equals the amount of water that can fit into the big one. So it's just a cool visual. Should we do practice? Okay, let's do the second practice. Problem 2. Ooh, word problem. Okay. Problem 2. So Rob draws a diagonal from one corner to the opposite corner on a square paper. If the sides of the square are 12 centimeters, find the length of the line to the nearest whole centimeter. And if you want to use a calculator for this one, you can. Yes. I see answers in the chat. 17 is the correct answer. So to use the Pythagorean theorem for this one, you look at the paper and you divide it in half like this because we want to look for the diagonal. And each of the legs are 12 centimeters long. And then this is going to be a right triangle. So you can use the Pythagorean theorem for this. So it would be 12, I'll write it up here, top of the screen, 12 squared plus 12 squared equals, and then we'll call the diagonal D. That's a weird looking D. D equals D squared. So that would be 144 plus 144 equals D squared. So that would be 288 equals D squared. Here, we're just going to use a calculator because it's easy. And so that gives D equals, so we square root both sides. So that gives D equals 16.97. So we're just going to round to 17 since it says nearest whole centimeter. So D equals 17. However, you guys have to be careful because this is a word problem and it's asking for the answer to the nearest whole centimeter. So you got to put units, guys. You have to write 17 centimeters. If you put 17, we're going to assume it's 17 like kilometers or something stupid. So make sure you always include the units here. So yeah, but yes, the answer is 17 centimeters. So good job. Okay. And like Yolanda said earlier, you can actually take a shortcut because there's only so many numbers there's only like certain sets of numbers that satisfy the equation a squared plus b squared equals c squared. So what this means is that there's like some right triangles that will like always come up. Like if you're like doing math problems in class or like you're doing a math competition, like you'll always see like the Pythagorean triples come up. So I think the most common ones would be like 3, 4, 5. So 3 squared plus 4 squared equals 5 squared. What this means is that if you see a triangle and they say, oh, this side is 3 and this side is 4, and they ask you for like the third side, if you memorize them, you just immediately know, hey, this side is 5. And then you don't even have to use the Pythagorean theorem. So 3, 4, 5, 6, 8, 10, 5, 12, 13. Those are like the most common ones. So if you want to take shortcuts, you can memorize these and then it'll make your life easier. So yeah. Oh yeah, and also if you multiply all the numbers in a Pythagorean triple by the same number, it gives you a new Pythagorean triple. So like if you multiply all the numbers in 3, 4, 5 by 2, that gives you 6, 8, 10, which is just another Pythagorean triple. So yeah. Okay. Kaya, you want to talk about this?
Sure. So now we can talk about 45, 45, 90 right triangles, which I like because they're simple to like memorize what the relationship is. So obviously 45, 45, 90, this means that this triangle is isosceles, and we can use that fact to create like this relationship between the sides. So if we label the legs, which are equal, as x, then we know that the hypotenuse is x times the square root of 2. So you can derive this just using the Pythagorean theorem, but I think you guys are good at that, so we can just skip over that part. But yes, always, it's like that. So let's see an example. Okay, find the length of side x. So don't get confused because we did say that legs were x in the previous slide, but here the legs are 5. So now to find the hypotenuse, all you have to do is multiply 5 by square root of 2. So what does that become? It does not become bananas. What is x? Yeah. So we don't have to put everything in like decimal form usually. So we can just leave it as 5√2. Yep, perfect. Very simple. Oh, yeah, here. They prove it in the slides. Should I do this too?
If
You
you
can
want
do
to.
it.
Okay.
Wait,
I
what?
can do it. I
Okay.
can. Yeah. Okay. So another special right triangle is a 30, 60, 90 right triangle. So what's special about this is that it has the hypotenuse as double the length of one of the legs. And then one of the other legs, so the longer leg, is square root 3 of that. So this is actually, it makes more sense when we draw it out as like an equilateral triangle, right? If we had an equilateral triangle and we just drew oh yeah.
Whoops.
If we had an equilateral triangle and we divided it in two, then we would get a 30, 60, 90 right triangle, right? And it makes sense that like we're going to divide the base in half, right? Because when we like drop the altitude down, like when we divide it in half, it makes sense that only half of a side is going to be equivalent to one base, right? So we get the x, and then we have the 2x from the like side length of because we know that one side like the hypotenuse has to be double the half leg because it's equal to one full side of an equilateral triangle. And then we could use Pythagorean theorem on this, right? So we know that x squared plus something squared is equal to 4x squared after we set up the Pythagorean theorem, right? And what we get is that 3x squared is equal to this longer leg, or is equal to this longer leg squared. So that would mean that x radical 3 is equal to this longer leg. And yeah. And these are like some of the like both 45, 45, 90 and 30, 60, 90 degree right triangles are like the most common right triangles or like pretty much the like main ones if you are doing something more than Pythagorean theorem on them. So yeah, it's important to know these. Okay.
Oh, oops. Sorry. I didn't see the okay, let's do. Oh. Okay, whoops. I just showed the entire slide, but wait. Wait, Ishani, let me find like a cooler problem to solve. Oh, okay, there's no more cool problems. Okay,
Cool.
very sad. Okay, let's just change the numbers. Actually, I'll just change. Okay, I'll change the numbers. So okay, you guys are going to be doing problem 2, but instead of this side length being 2, it'll be like 4. There, problem solved. Okay.
Yeah.
So
Well, think about the steps you need to take to find the area, and then like what you have missing, and then in the equation for the area, and then try to solve. I'll give you all like a minute, and then
yep, remember. Okay, focus on the problem right now. But remember, we're finding the area of the triangle. So finding the side lengths will help. But remember, ultimately, you're looking for the area.
Okay, so I see a lot of you are saying like you found a side length. Remember, we are trying to find the area, as Amy said.
Yes, so most of you guys are halfway there. You just gotta find the area now.
Mhm. Okay, I'll wait for a few more answers and then okay, so you can leave your answer in like radical form if you want, by the way. Okay, so I'm seeing a few answers, so I'm going to start explaining. Right, so what we know is we want to find the area, right? So when we know that we're trying to find something, we should like always try to like set up an equation for how to solve for this so we know what we need to find. Because sometimes you'll have unknowns and problems that you don't need to solve for to find your actual answer, right? So we need to know 1/2 base times height to find area, right? So the base here is 4, right? So we have 1/2 times 4 times and then whatever y is, right? Because y is the height. So this is what we are going to solve, right? So we only have to find y. We don't care about x, right? So remember earlier, we said that the ratio of the sides is for the shortest side, for the shortest leg, it's 1 times some variable or times some constant, and then it's the hypotenuse is 2 times this constant, and then the longer leg is radical 3 times this constant, right? So we know by that this y has to be equal to 4 radical 3, right? So this is equal to 1/2 times 4, which is 2, multiplied by 4 radical 3, or 4 square root 3, right? So that is equal to 8 square root 3. So that would be the area of the triangle on the left, right? And if we were to like see what the value is, right, like the decimal, then that's equal to like 13 or sorry, yeah, it's equal to 13.85, which is approximately 14. But you do not need to like see it as a decimal, right? You only need to say it as like a radical because that's more exact. So yeah, yeah, good job if you got it. Do you all have any questions? Okay.
Okay, wait. How much longer should I go through the slides? Because I know we have a bit left.
Should we do the book?
Yeah, because we have 12 minutes. So
Okay. Then we shall go straight to the booklet. And by the way, the other stuff that we aren't covering, but are on the slides so you can look at it later, are area of an equilateral triangle. Oh, that's it. Okay. Well, okay, then for the
Amy,
people
you have to show the quote. You have to show the quote.
I know. Hold on. If anyone really wants to know, this is the formula for the area of an equilateral triangle. So if you really want to know it, you can take a picture right now, and that's the area of an equilateral triangle. S is side length. So, so yes. Okay, now moving on. Here is the quote. Yolanda, you should read it in a very dramatic voice.
When in the course of human events it becomes necessary to review mathematics, one relies on the almighty Blukit.
Woo!
The crowd cheers.
Thank you. Thank you.
Okay, put your game request in the chat, but don't spam. If I see spamming, I'm not gonna do that one. Okay, I see one battle royale, not two. I see one gold quest. I see two crypto hack. I see two gold quests. Okay, everything's tied right now. I see three crypto hack. Anything else? Right now, crypto hack is in the lead with 3, I think. Okay, I think we're doing crypto hack based on. Okay, we're doing crypto hack.
Crypto hack. No.
I saw one more person put crypto, so that's why. Okay.
Yeah,
Uh,
what's the roof said?
Okay. Oh man. How about we do Battle Royale next time?
Wait, what's the shortest time you can set on Blue-Kit?
Shortest? As short as we want it to be. Uh-oh. What happened?
Bruh.
Oh shoot, did I say it last time? Hold on. Oh bruh, okay, hold on. Let me re-log in. What the heck just happened, bro? Bro, Zoom. Hello? Okay, I guess okay, fine. Let me write it on my like a paper and I will do Battle Royale next. Oh my goodness gracious. Okay, I will actually do Battle Royale next class. I will write it down once I get through the thing.
I'll remind Amy.
Yes, please. Okay, new game code, whatever it is. Okay. I'm muting this tab. Okay, let me find a piece of paper. Ooh, I got it. I'm gonna give Jaguar the paper so he can remind me. Oh my god. Yeah, yes, because Jaguar's gonna make a showing next class, so he's gonna have to remind me to do it. So I'm gonna give him a piece of paper that says do Battle Royale next class. Yes, true. Okay. Okay, give me a second while I put Jaguar. Okay. Does anyone else need time to join?
Yes.
Okay. Bunny approves of your avatar. Is this a jaguar? I don't know if this one's a jaguar. Either way, Bunny does not approve of that avatar. Okay, if anyone else needs to join, you better say it now because I'm gonna start.
If you think that Jiva Fazbear is a real player, he's not, because he just like got kicked out. My computer stopped working for a
Uh-oh.
second.
Wait, can you still join in the middle? I think you can.
Yes.
Okay,
Yeah,
I'll
you
just
could.
start it.
Yeah, you can.
Okay. And the battle is on. Actually,
Yes.
I'm gonna join too. Although I'll be behind. Okay.
I got triple crit though.
Whoa. We have 40 seconds left. Whoa, game over. High is third place. High is second place. What the frick? And in first place, we have James. Yay. There
Huh?
are literally two highs. Wait, are these are different people, right?
I'm the third place one. So yeah.
So first was
Oh.
I and I.
That's crazy. I hacked a high person and then I got to hack a second high person. I was really confused. Good job.
Same
Okay.
thing with Garish.
Yes. That's crazy. Okay, yay. Good job, everyone.